I looked at the review today for test 4 and noticed that it's missing a few examples of quadratic word problems. So here are 3 examples that I would encourage you to look at prior to testing. Question 1. If the product of two consecutive integers is 143, find the numbers or find the integers. Well, what I know is I'm going to let x be the first number. And if x is the first number and they are consecutive integers, in fact, I'm even going to go further and say consecutive odd integers. I forgot that number or that word. It's very important. For consecutive odd integers, the first number is going to be x. The next odd integer we would say is x plus 2 to keep them odd is my second number. Now the product. The product means we will do x times x plus 2, and the product is 143. All right, so I'm going to start by simplifying this, and to simplify, I will distribute the x through, and I get x squared plus 2x now is equal to 143. Notice that it's now quadratic. I have that x squared, which means I'm going to need to factor to solve. But to factor to solve, I have to get everything equal to 0. So I would subtract the 143 from both sides. And it would be equal then to 0. Getting my answer area ready, since the lead coefficient is a plain x squared, meaning the lead coefficient is 1, I will look for the factors of 143 that add up to a positive 2. In fact, it's a negative 143. Well, the first two numbers that I think of, because I go through all of the factor pairs, and 1 isn't a factor, 2 isn't a factor. No, in fact, no even number will be a factor. 3 isn't, 5, not 7, not 9, but 11 is a factor. And 11 times negative 13 is 143. But notice when I add them together, rather 11 times negative 13 is negative 143. But when I add them together, I get a negative 2. It only differs by negative sign, so it's not correct, but it's close. And I know how to fix this. I change the positive and negative signs on the factor pair. You'll see that negative 11 times 13 is negative 143, and their sum is 2. So that would be how my quadratic part on the left-hand side factors. But I need to finish solving. So I'm going to let each of these factors equal 0. And solve. So for x minus 11 equal to 0, then x is equal to 11. And x plus 2 is 13. All right, well, that does satisfy what we need. They are two consecutive odd integers, and the product is 143. All right, for x plus 13 equal to 0, I get x is equal to negative 13. And x plus 2 is negative 11. Well, their product is positive 143, and they are two consecutive odd integers. So how I would express my answer, because we have two sets of answers, and they're both good. So the numbers are 11 and 13, or negative 11 and negative 13. That's how I would express my answers. Next example. The length of a rectangle is 2 meters longer than the width. If the area is 24 meters squared, find the length and the width. So let's go ahead and just draw a picture of this rectangle. I have the length, I have the width, but it says that the length is 2 meters longer than the width. So if the width is W, the length would be equal to W plus 2. I know their area is 24 meters squared. Okay, well, The formula for area is area is equal to length times width. And substitute in what you know. I know the area is 24 meters squared. I know the length. Well, let's replace it with the W plus 2 because then it's down to one variable. I distribute to solve. So I have 24 is equal to W squared plus 2W. Oh, I see it's quadratic. So I'm going to put everything to one side by subtracting the 24. And since this lead coefficient is a 1, I look for the factor pairs of negative 24 that add up to 2. And I know, I could go through them all, but I know that it is 6 and negative 4. So in solving, we have W plus 6 is equal to 0. So W is equal to negative 6. Now, if that's the width, it doesn't make sense because it would be a negative length. But if W minus 4 is 0, then the width would be equal to 4, and the length would be equal to 2 more than 4 or 6. So we would say that the length is 6 meters, and the width is 4 meters. One more example. One leg of a right triangle is 1 foot less than the hypotenuse. If the other leg is 5 feet long, find the length of the hypotenuse of the triangle. So let's go ahead and draw a picture for this one as well. So it tells me that we have a hypotenuse that we want to find. So I'm going to let x be the hypotenuse. One leg of the right triangle is 1 foot less than the hypotenuse. Okay, so I'm going to label one leg. Remember, the legs are the two shorter sides of a right triangle, and it would be x minus 1. The other leg is 5 feet long, so I'll label that as well. All right, well, we have a right triangle, and we want to know the length of sides. So what we have with this is the Pythagorean theorem. A squared plus b squared is equal to c squared. Right? So let's go ahead and put the information in that we know. So one leg is 5 squared plus. All right, the other leg is x minus 1, so x minus 1 squared, and it'll be equal to the hypotenuse of x squared. All right, scratch paper needed to simplify because I have to figure out what is x minus 1 quantity squared. I need to clear the parentheses. So x minus 1 quantity squared is the same as x minus 1 times x minus 1. And you can go ahead and FOIL if you like, or you can see that this is going to simplify to x squared minus 2x plus 1. So I'm going to go ahead and put in x squared minus 2x plus 1, and it is equal to x squared. So it is simplified. Or it's not simplified, but we did get rid of the parentheses, and I'm going to combine like terms. I'm also going to subtract this x squared from both sides. And in doing that, it cancels off. So we end up with 2 minus 2x plus 26 is equal to 0. Minus 2x is equal to negative 26. And if you divide both sides by negative 2, x is equal to 13. So we could say x is equal to 13 feet is the length of the hypotenuse. And that would be the answer. So again, I wanted to give you 3 examples of good quadratic word problems for our